Okay. So we're just gonna do some sample ones. Now, the assignment yesterday was all like story problems and stuff. There aren't gonna be any story problems on this one. It's just, you have a multiplication one, you have a divide one. You have a multiplication one, and you have a divide one. I didn't do any addition, but I did do multiplication and division. Okay, so let's do, give me a number, random number.
10.
Not 10.
16.
1.6 times 10 to the
42nd.
42nd times by
3.
3 times 10 to the
36.
36. Okay. So I'm multiplying, all I'm doing is I'm multiplying numbers in exponential form. This is no different than 5x squared times 3x to the fourth. If I have 5x squared times 3x to the fourth, what do I multiply first? What do I multiply first? 5 times 3 is what?
15.
15. And then I have my x's, x squared and x to the fourth. So that's x to the what?
6.
How did you know it's 6?
Because when you're multiplying exponents, you just add them.
When I'm multiplying numbers in exponential form, I add the exponent. So 15x to the 6th, okay? So that one's pretty straightforward, and we're used to seeing x's. But now, the number in the exponent, or the base for the exponent is just 10, okay? I can't combine it with my regular numbers, and I'm not going to because they don't have an exponent. They're a different base. Same base, no exponent, no exponent. So I multiply these two. Well, what's 1.6 times 3?
4.8.
4.8. It's 3. You, Ethan, you were doing 3 plus 1.8. You were dividing it up, but then you just kind of made a mistake. So what if you can't do 1.6 times 3 just like that? You can math it out by hand. Do I care if you use a calculator?
No.
No, I don't. So it's 4.8. Okay, so it's going to be times 10 to the something. I don't know what. So I'm multiplying numbers in exponential form. So what do I do with their exponents? Add them. What's 42 plus 36? 78. What do I do now? There's one last step I'm missing.
Write out all the zeros.
Do not write out all the zeros. Circle it, and then I move on with my life.
Can
Okay?
you do negative exponent practice as well?
Can I do? Yes, I'll do. We're going to do 2 multiplication, 1 negative and 1 positive, and then we'll do 2 division, and then we'll see where we are. Okay. So give me a number.
46.
4.6 times 10 to the negative 3. See what I did there? Times. Give me another number. 4.3 times 10 to the 14th. I have 1 positive and 1 negative, okay? Can we do that? We can do it. All right. What's 4 point? Okay, so first step. What's my first step? Braddock.
See what 4.6 times 10 to the negative 3 is.
No, that's not my first step. We're not gonna expand that out. It's in scientific notation. I don't want to deal with the scrillion zeros. I'm happy. So what's my first step gonna be? What is it really gonna be, Braddock?
Multiply the numbers.
Multiply just these bare numbers with no exponents on them. So what's 4.6 times 4.3?
19.78.
Thank you, because that's not math I can do in my head.
Harmonics.
19.78 times 10 to the what? All right, so I have 10 to the negative 3 times 10 to the 14th. When I have numbers in exponential form, I add their exponents. Braddock.
It would be 11.
Negative 3 plus 14 is 11 because it's the same as 14 minus 3. 14 minus 3 is 11. Am I done?
No.
No, why not?
It's circle.
I
Actually, it's circle.
need to do one thing before I circle it. I'm actually legit not done. Is this in true scientific notation?
Oh, is it? It has to be a the decimal.
We only need one number number to the left of the decimal, and right now we have 2. So I need to fix that. So this is equal to 1.978. So I moved the decimal point to the left. So does this get bigger or smaller? How many places did I move it to the left? 1. So by how many bigger does this get? 1. So times 10 to the 12th. Now, Abram, what do I do? Circle it, and then what? I move on with my life. Circle it and move on with your life. Okay?
Are we gonna learn about square roots this year?
Yes,
Oh, no. Yeah.
but not today. All right, should we divide some? Give me numbers, random numbers.
46.
What?
46.
No, like, can we move past
48.
the 46?
48.
Like, we're doing 46, like on every single one.
56.
4.6 times 10 to the 56 divided by what?
840.
3.8 times 10 to the 42nd. You said like 842. I guess we could. Why not? 842.
No.
Who cares? Right?
It's just math.
All right. It's just numbers. It's big numbers.
Just math and numbers.
4.6. What do I do first? After 4.6, after 4.8, what do I do with these numbers?
Divide them.
Divide which ones?
The empty numbers.
I divide the empty numbers, like the numbers without exponents first, right? What's 4.6 divided by 3.8? I can't do that in my head. Braddock.
1 1/3.
Okay. No, I would really prefer to. We need to keep it in a decimal. We don't.
1.33.
Is it 1.33? Is that what
Yes.
you've mathed it?
It's 1.33.
6316.
I'm gonna believe the people with the calculator. Sorry, bud. 1 point what?
It's 1.3.
2631.
So okay, I'm gonna write down.
1.27. Just 1.27.
Abram, you be quiet. I can't. My brain. I can't listen to 7 people. Abram, what is it?
1.210526316.
Okay, so we need to have a conversation.
Okay, 1.27.
Do I need to write down this many numbers?
No.
No.
Just move it to 1.
My data was given to me with 1 decimal place. So what do I need to finish with? How many decimal places do I
Round
finish
it
with?
to the nearest hundredth.
Round it to the nearest 10th. My data was given to me. If I have, in science, which is where we use scientific notation, your answer cannot be any more precise than your data. My data is precise to 1 decimal place, so guess how I'm going to end? To 1 decimal place. Now, some of you rounded your answers on your assignment yesterday and you rounded incorrectly. We haven't talked a lot about rounding, so I let it go, but we need to watch our rounding, okay? This is 1.21. If there is a 1 right here and I'm rounding to this place, what does the 2 round up or does the 2 round down?
2.
I mean, does
Or
it
it
stay
stays
where it
the
is?
same. 2.
It either stays where it is or it pumps up to 3. Does it stay?
2.
Because this is a 1, it's less than 5. So I'm actually going to go ahead. Where's my pen? I'm going to just erase this for my answer. Now, here is the biggest rule about rounding in the world. Should we scroll and show you why? Do not ever round in the middle of a problem. If you round in the middle of a problem, you might end up with 1 + 1 = 3 because you have large values of 1. Should I show it to you? We're squirrel in a minute, but this is valuable, okay? What's 1.4 plus 1.4 equal to? 2.8. Let's round all of these. What does 1.4 round to? 1. What does 2.8 round to? Does 1 + 1 = 3? No. 1 plus 1. So if I had rounded at the start, I would have had 1 + 1 = 2 when my answer should have been 3. Don't round until the end. Keep all your decimal places until the end and then you round because you get what's called rounding error, and rounding error can get really, really big, really, really fast. And you will be on some of our, like when we're doing, when when we're doing like similar triangles and dilations and things, your answers will be 50, 75 off if you round in the middle of the problem. And it will be so wrong. Okay, don't round in the middle of the problem. Squirrel movements with Mrs. Barlow, but that was a good one. So 1.2 times 10 to the numbers in exponential form, and they're being divided. So what do I do with them?
Subtract them.
Subtract it. What's 56 minus 842?
Negative 786.
Negative 786. What do I do now?
Circle it and move on with your life.
Sophie!
You put the 10 to the negative 786 on the bottom.
Okay.
No.
I love that you said that. In every other exponential problem, it is in simplest form when you do not have a negative exponent. But in scientific notation, we keep it in a straight line and we accept the negative exponent.
Oh.
Okay?
Circle it and move on with your
We
life.
circle it and we move on with our life. And we get, Sophie looks like she's smelling bad smells. She's like, but it's wrong! Because she knows it's wrong and it's wrong. And if this was 1.2, oh wait, that's 1.2. 1.2 x to the negative 786, I would say, yeah, that x needs to pop down and we have 1.2 over x to the 786. Every other instance, you do this, but not in scientific notation. Scientific notation, we keep it in a nice straight line, and we just know that this is a very, 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 very small number.
Just circle it and move on. with your life.
1.2 times 10 to the negative 786, that's like,
Circle it
I
and
don't know, the size of a virus compared to the sun or something. I mean, it's small. Smallity, small. But are small things a reality?
Yes.
Do we need little tiny exponents like that? We need a way to express extremely small numbers easily, and that's what this does for us. Okay, one more. Let's do another debate. Oh my gosh, you suckered me into the 4.6 again. How did that happen? Oh my gosh.
46.
We're not doing 46. Oh,
46.
we're gonna completely,
46.
look, we've got
46.
sixes and sixes, like, branch out, people.
84.
9.7
66.
Okay.
times 10 to
To the
the
66.
36.
666.
Back to back.
10 to the 33rd.
Yes.
Okay?
Ah, that's
Divided by
83.
2. There are no, look, there are no 2s.
23. 23. 2.5.
25. There are also no 5s. So let's give
2.5.
some love to the 5. 25 times 10 to
460.
the negative
46.
66.
Negative 46.
66. So let it be written.
46.
40. 46.
Sometimes we don't get our way in this world. And we
I
just,
know. but
and we
the
just
46
move on
will
with
be
our lives.
fine.
Okay. We're dividing numbers in exponential form, but these little guys right here are not in exponential form. So what's 9.7 divided by 2.5? I can't do this math. I choose to not do this math in my head. But Sophie's calculating it out for me. What is it?
It's 3.88.
3.88 times 10 to the, oh, right. Ooh. I'm dividing numbers in exponential form, right? These are exponents. So what do I do with the exponents? I subtract them. So I have 33 minus a negative 66. When I have two negatives in a row, I'm going to call one of them an opposite. 33, and then we have the opposite of subtracting this 66. What is the opposite of subtraction?
Adding.
Addition. What's 33 plus 66?
No.
We have 3.88 times 10 to the 99th. That's a 10 with 99 zeros after it.
Hey, that's one less than Google.
That's one less than a Google.
Wait, is one less than a Google search? That's one less than a Google search?
Okay, so the search engine, okay. 10 to the 100th power is called a Google. The search engine Google was named after the number, not the other way around.
It's a Googleplex.
A Googleplex is a Google to the power of a Google. Okay. So, but the search engine Google will give you this many answers is kind of the premise behind it. It won't, not really, but there we go. So what's my last, so I will take it if you give me 2 decimal places, but ideally we should round. 3.88 rounds to what? 3.9, because this guy is bigger than 5, right? So 3.9 times 10 to the 99th. Significant, I'm a little bit, I hear people talking over there, please don't. So I'm a little more relaxed in math. In science, it really, really is important because the number of decimal points that you report indicates how precisely you've made your measurements. Sometimes you're going to be able to make your measurements precise to like 4 or 5 decimal places. Oh, so fun when that happens. And sometimes you're not, but you can't report that you were more precise than you actually were. Does that make sense? Good. So anyway, it's a big deal with science. How do we feel? We feel a little bit better than we did like 10 minutes ago about this stuff. Okay, I just think we needed a little bit more practice. Now the story problems, they throw people for a loop, but you just have to remember: am I multiplying? Am I adding? Am I subtracting? Am I dividing? And if you don't remember that, I can help you. But there are no story problems on this one. We're just doing the math. Okay. All right. I think we're good.